one thing you should be able to do is full expansions. And now this is unlikely to come up in the exam, but you should still be able to do it. And it's worth just going through a few examples just to make sure you actually know the formula well. So the formula that we will be using is, well, the sum starting at k equals 0 and ending at k equals n of n choose k multiplied by a to the power of n minus k times b to the power of k. And a and b are your two nomials, your two things in the bracket. So here we'll have a will be 2x and b will be minus 3. If we follow the formula, you'll see me start to write it out. 4 choose 0 times 2x to the power of 4 times minus 3 all to the power of 0 plus 4 choose 1 times 2x. And we'll put that to the power of 3. Then multiply that by minus 1 to the power of 1. And then we keep increasing the k as we go along. And we keep decreasing the power of 2x as we go along and increasing the power of minus 3 as we go along. So we're choosing one more each time, and we're reducing the power of 2x by 1 each time and increasing the power of minus 3 each time. So 4 choose 0 is 1, anything choose 0 is 1 because that's the 0th row of Pascal's triangle. We'll multiply that by 2 to the power of 4, that's 16, so 16x to the power of 4. And remember, minus 3 to the power of 0 is just 1. And then next, we know the next one's going to be negative because we've got minus 3 to the power of 1, an odd power. And 4 choose 1 is 4, anything choose 1 is itself. And we multiply that by 8, which is 2 cubed, so that gives us minus 96x cubed. Then 4 choose 2. Now, you could just draw out Pascal's triangle to figure these combination numbers out, or you could just type it into your calculator. So that'll give us 216. Then 4 choose 3, which is 4, multiplied by 2, multiplied by negative 27. That will give us negative 216, and then 4 choose 4 is 1, multiplied that. Now 2x to the power of 0 is going to be 1, so we just multiplied by 3 to the power of 4, so it's going to give us 81. Okay, so next example, we'll have x squared plus 3 over 2x cubed. And we'll raise all of that to the power of 3. Now, I would recommend just rewriting this at the start. If we use the exponent rule of 1 over x to the power of n is equal to x to the power of minus n, we'll get 3 over 2. Remember to split up the fraction. Do not make it 6x to the power of minus 3. Make sure you keep the 3 over 2. And we'll raise that to the power of 3. That just kind of makes the algebra a bit easier, reduces your chance of making mistakes. So 3 choose 0 times x squared to the power of 3. And then, well, hopefully you'll be very familiar with this now. It does get very repetitive, I know. You just increase the number of objects you're choosing. You decrease the power of x squared and you increase the power of 3 over 2x to the power of minus 3 as you go along until you reach 3 choose 3. Alright, so the first term is just going to be x to the 6th. And we're going to get 3 multiplied by x to the 4th, multiplied by 3 over 2, multiplied by x to the power of minus 3. So if we put that together, we've got 9 over 2, x to the power of 1. We'll do 3 choose 2 multiplied by x squared. So 3 choose 2 is 3. Multiply that by 3 over 2 all squared. So that's going to be 27 over 4. And if we do the powers, we're going to get x to the power of, well, minus 4. Which we can just rewrite with as x to the 4 in the denominator. And it is conventional to write it in the form that they give you in the question, so you would do that. Then for the last one, 3 choose 3 is 3. Multiply that thing to the power of 0, which is just going to be 1. So you end up with just 3 over 2 all cubed, so 27 over 8. And that's x to the power of minus 9. So you just put the 9 on the bottom in the denominator. Okay, so our final example is going to be 5 minus x over 2 to the power of 4. Now the first thing I do, just to make sure I don't make mistakes, I'll rewrite it by taking out the 1/2 and just making it a proper coefficient. And then I just apply the same formula. I mean, hopefully you are very familiar with this now. You start with n choose 0, then keep increasing up to n choose n. You decrease the power of your first term in the bracket as you go along, and then you increase your power of the second term in the bracket as you go along. Then you just plug your numbers into the calculator. You may have to use shift to get your combinations, but you will learn a lot of the smaller values of Pascal's triangle pretty quickly. And then, so you just put that in the calculator, then you just have to be kind of mindful of your x powers. But seriously, as my maths teacher used to say, any moron can do this. So you might have to find a specific term or coefficient. Now a term, in general, it will contain a letter. It doesn't have to, but if it asks you, for example, say the term with x squared, then it's going to contain a letter. But the coefficient is just the number. So the coefficient is, say the coefficient of 9x squared is 9. So the 9 is the coefficient, the x is the variable, and the 2 is the power. Now there is also an invisible fourth part in front of the 9, that's the sign, because for positive numbers we don't write a positive sign in front of the numbers. However, for a negative number, so if this was -9, the sign would be negative. And the coefficient would also be -9. Here's an example. Find the coefficient of x cubed in 3 minus x to the power of 5. So the expansion of 3 minus x to the power of 5. So we can say that our general term is n choose k times a to the power of n minus k times b to the power of k. And so we can just write in whatever we know. So we know that n is 5 because n is the power of the bracket. A is 3 and b is minus x. And we want to try and get this to be some coefficient, which is just a number times x cubed. So this 3 is just a constant. So we can immediately know that the k we need is going to be 3. So then we'll do n minus k, which is going to be 2 times minus k to the power of 3. And this is going to give us, 5 choose 3, I believe is 10. And if we multiply that by 3 squared, and then by minus x cubed, we get negative 90x cubed, which means our coefficient will be minus 90. Minus 90x cubed is the term, but it asks for the coefficient. So then maybe it's going to ask find term containing x cubed in the expansion of 4x plus 3 to the power of 5. Once again, general term is just going to be n choose k multiplied by a to the power of n minus k multiplied by b to the power of k. So we just write in whatever we know. So we know that n is going to be 5. We're going to set a to be 4x and b to be 3. Once again, because 3 is just a constant, we know that 5 minus k has to be 2. And then simple rearrangement will mean that we know that k equals 3. So now we just substitute the 3 in. So we get 5 choose 3 times 4x squared times 3 to the power of 3. So 5 choose 3, that's 10, so we multiply that by 16 and by 27, multiply that by x cubed. So that's going to give us 160 times 27, which is 4,320 x squared. And that is our term. Now 4,320 is the coefficient. Additionally, to make it more like the previous example, we can switch around the 3 and the 4x, because 4x plus 3 to the power of 5 is equal to 3 plus 4x to the power of 5. This is due to because of the commutative law of addition, meaning order doesn't matter, you're still going to get the same sum. And so this means it's going to be equal to 5 choose 2 times 3 to the power of 3 times 4x squared. And that will be equal to 5 choose 3 times 4x squared times 3 to the power of 3 because of the commutative law of multiplication. So this all can work because, Pascal's triangle is symmetrical as well. And so whatever way you do it, it'll give you the same answer. Now these types of questions can get more challenging when both A and B contain an x term, or any common variable for that matter. So for example, if you were asked to find the term in x to the power of 11 of 3x to the 4th plus 1 over 2x all to the power of 4, what you would first do is just rewrite this into a proper coefficient and a negative power in your b term, because this is, again, due to the rule of 1 over x is the same as x to the power of minus 1, and 1 over x to the power of n is x to the power of minus n. And so your general term, again, is going to be n choose k times a to the power of n minus k times b to the power of k. And you just put in what you know for now. You don't know your k, you're trying to find out which k you want to use, but you know your n's going to be 4, and you know your a and your b. And you want this to be some coefficient multiplied by x to the power of 11. So for now, you can ignore all the numbers and coefficients and just concentrate on the x's. So you can rewrite this as x to the 4, bracket, to the power of 4 minus k, times x to the power of minus 1, bracket, to the power of k, equals x to the power of 11. And we can use another exponent rule, x to the power of m, bracket, to the power of n is x to the power of m times n. So this means that we're going to have x to the power of 16 minus 4k times x to the power of minus k equals x to the power of 11. Then we can use another exponent rule of x to the power of m times x to the power of n equals x to the power of m plus n. So we get 16 minus 5k, because adding a negative is the same as subtracting. And then if both bases are the same, we can say that 16 minus 5k equals 11. So minus 5k equals minus 5, and k equals 1. So good news, we found our k. You could also do trial and error. I prefer just to do a way that I know is going to be correct, and yeah, and it just is tidier layout. So 4 choose 1, so you know your term is going to be 4 choose 1 times 3x to the power of 4. Now 4 minus k here is going to be 4 minus 1, which is 3. Then you multiply it by 1 over 2x to the power of minus 1 to the power of 1. And this is going to be 4 times 27 times 1/2 So that's going to be 54. And, well, you know it's going to be, you're going to have x11 on both sides, hopefully. And your coefficient is there. But it asks for the term, so you leave your answer as 54x to the power of 11. Okay, so finding term independent of x. This is another very common question type in this topic. So the term independent of x just means it does not contain x, i.e. a constant. And you could say term independent of y if your expansion was like y plus 5 to the power of 10 or whatever, you know. But the point is any variable can work, but the point is it's a constant. So what about the example 3x plus x to the power of 5? Very simple example. This is very easy because, well, we know that we have a constant term in the bracket anyway, so the constant term would just be 3 to the power of 5, which is 243. Get a bit more complicated if you had it, your A and your B both containing some x. So for example, the expansion of 2x to the power of 5 plus 1 over 4x squared to the power of 6. You'd start off with your general term being n choose k multiplied by a to the power of n minus k times b to the power of k. So we'll put in what we know, 6 choose k times 2x to the fifth to the power of n minus k times, well, 1/4, split up the negative power and the coefficient, and put that to the power of k. And we want this to be some coefficient times x to the power of 0, because x to the power of 0 is just 1. Anything to the power of 0 is 1 except for 0. Okay, so then once again we're going to ignore our coefficients for now and just worry about finding k. So if we set these to all equal 0, and then we use the same exponential laws as before, we'll end up with this. Oh dear, my apologies. That should be to the power of 1, not 2. But that's fine, not major. If we just replace all the negative 2's with negative 1's, then we'll be back on track. We add together those powers. We get 30 minus 6k equals 0. Minus 6k is minus 30. Or 6k equals 30, and so k is going to be 5. Apologies, folks, for that. So then we just put in our 5. And then you should know the drill by now. We'll just simplify this and evaluate. So here's another question type. It's given that the coefficient of x squared in the expansion of 1 plus ax to the power of 4 is 30 times the coefficient of x in the expansion of 1 plus ax over 3 to the power of 3. So pretty much, I haven't written here, but we're going to try and find a. So we can first figure out which one's going to be the x squared coefficient. So just go, and it's lucky that only one of them is in terms of x. So that means we instantly know we're going to have to raise it to the second power. So do 4 choose 2. And we know for the other one, instantly we know we're just going to have to raise the ax over 3 to the power of 1. And then so we can just remove the x and x squared to get the coefficients times the a by 30. 6a squared equals 30a, 6a squared minus 30a equals 0. Factorise that. A can't be 0. So that means 6a minus 5 equals 0, 6a equals 5, and a equals 5/6. And then there is a second part of the question. It says, hence, find the term independent of x in the expansion of x squared minus a over x squared to the power of 4. Right, so we can just replace a with our 5/6 and then get rid of that x squared in the denominator and make it x to the power of minus 2. Then straight away we can just say 4 choose k multiplied by x squared to the power of 4 minus k times 5 over 6, or minus 5 over 6 times x to the power of minus 2 to the power of k is going to equal some coefficient times x to the power of 0, which we know is 1, and that makes it independent of x. So using those same exponent rules and just ignoring the coefficients for now, we get the k we need being 2. And this was perhaps fairly easy to see without having to go through this whole process, but it's good for layout and to make sure you don't get it wrong. So we just replace all our k's with 2. And then we know the x's are going to cancel out, so we don't really need to worry too much about them. But 4 choose 2 is 6. X squared is 4, x to the 4th, sorry. Minus 5 over x squared is going to be 25 over 36 because all numbers squared are positive, and that's going to be x to the power of minus 4. That x to the 4th and x to the power of minus 4 will cancel out. 6 times 25 over 36 is just 25 over 6, which is our answer. Here's another example. In expansion of kx plus 2 over x to the power of 4, where k is positive and it's a constant. The term independent of x is 150. From this information, just find the value of k and hence determine the coefficient of x squared in this expansion. So we get 4 choose, say, r times kx to the power of 4 minus r. We have to use r because we've already got k in the question, times 2x to the power of minus 1 to the power of r. It doesn't really matter what letter you use, but I'm just going to use r. And set that to equal 150, x to the power of 0. Just to make that, I add that just to make it clear to the viewers that we're just trying to find the one independent of x. So if we remove all the coefficients and we just get 4 minus 2r equals 0, we'll see that to get an end result of x to the power of 0, we want r equals 2. So 4 choose 2 times kx to the power of 2 times 2x to the power of minus 1 to the power of 2 equals 150. And then if we get that 6, then multiply it by k squared times 4, that's going to be equal to 150 because we know the x's are going to cancel out anyway. So that gives us 24 k squared equals 150. K squared equals 150 over 24, which will simplify down to 25 over 4. And then to get k, we'll take the positive root of that. And so that'll be 5 over 2. Then for the second part of the question, we'll just do that down the side here. We want to get x squared. So we have the same thing. We want x to the power of 4 minus r times x to the power of minus r to equal, or x squared. 4 minus 2r is going to equal 2 this time. and that means we're going to get 2r is going to equal 2 and r is going to equal 1. So then we just change all the 2's in the previous one for 1, so now 4 minus r is going to equal 3. So 4 choose 1 is 4, multiplied by 125 over 8 times by 2. And this is going to be, in fact, 8 times 125 over 8. And technically, as we did include x's in that, we do need to add in our x squared. But it just wants a coefficient, so we just leave our answer as being 125. So another problem could be find in ascending powers of x the first 3 terms of the expansion of 1 minus x multiplied by 2 plus x to the power of 7. Now, if you're unsure about how to approach a binomial expansion problem, you really don't know how to crack it, just write out the full expansion. It'll get you the marks. It'll take time, but at least you'll get the marks. However, in this case, we don't need to do the full expansion. Instead, just, if you think about it like this, your 2 plus x to the power of 7 is going to end up being some constant plus something times x plus something times x squared, etc., all the way up to x to the power of 7. That's what it's going to look like. And then on the other hand, you've only got a 1 and a minus x. And because we're only looking for the first 3 terms, so that's going to be your x to the power of 0 term, your x to the power of 1 term, and your x squared term, because it's ascending, you only need the ones that are going to end up as x to the power of 0, x to the power of 1, x to the power of 2. And if you actually do some vague multiplication, you'll see that only 5 of the 14 terms that you're going to end up with actually need to be calculated. All the ones beyond x squared times 1 are going to be more than higher degree than x squared, and all the ones beyond x to the power of 1 times minus x to the power of 1 is going to be beyond x cubed, or beyond x squared. So just find the first 3 terms. You see that all you need to do is find the first 3 terms of 2 plus x to the power of 7, and you know this, you can do this extremely fast. 7 choose 0 times 2 to the power of 7 times x to the power of 0, etc., etc., etc. And this is going to become 128, and you're going to get 7 times 2 to the power of 6, which is 448, and 7 choose 2, which is 21, multiplied by 2 to the power of 5, which is 32. It's going to get you 672. And because this gets multiplied by 1, they'll stay the same, so already we have found 3 out of the 5 terms we need. And then we just need to multiply our 128 and 448x, both by negative x. So now we are ready to find the first 3 terms of 1 minus x bracket multiplied by 2 plus x bracket to the power of 7. If we just we'll rewrite those terms there, then we'll minus 128x because we're multiplying out the minus x in that bracket, minus 448x squared. Then you still have 128, but then you have 320x and 224x squared. This one here isn't always going to be 1, and so they're not always going to be the same as the one in your big expansion, so you just have to be mindful of that. Say if it was 2, you'd have to multiply 2 by 128 and by 448x and by 672x squared. And then you'd add on your minus x multiplied by 128 plus 448x. Here is another problem. Find the first 3 terms in the expansion of 2 plus 2y minus 3y squared to the power of 10 in ascending powers of x. Now this here in the bracket, that is a trinomial actually, because there's 3 terms, not a binomial. So what you would do is let x equal 2y minus 3y squared. So then the expansion becomes 2 plus x to the power of 10, which is a binomial again. So let's first calculate the first 3 terms in terms of x. You'll know this, 10 choose 0, then you go up to 10 choose 1, then to 10 choose 2. And then you're decreasing the power of 9 and you're increasing the power of x. So this will become 1024 multiplied by, well, plus, sorry, 5120x plus, well, 45 times 256x squared, whatever that is. So then we can replace our x's with 2y minus 3y squared. So now we must expand this 2y minus 3y squared, bracket squared. So it's going to be 4y squared minus not 6, it's going to be minus 12y cubed plus 9y to the 4th. So then we only really care about that 4y squared because we're only trying to go up to y squared. So then if we expand this, we're going to get 10,240 and then minus 15,360y squared. Then if we multiply the 11,520 by 4, we're going to get 46,080 y squared. And then so we just collect those like terms. We get 1,024, 10,240y, and 30,720 y squared. So the final problem will be find in ascending powers of x the first 3 terms in the expansion of 1 minus x over 2 to the power of 8. And from there, obtain the coefficient of x squared in 2 plus 3x minus x squared, bracketed, multiplied by that thing, 1 minus x over 2 to the power of 8. So the first thing we will do is to find the first 3 terms of 1 minus x over 2 all to the power of 8. This is very simple by now. you literally just use the formula, start from h is 0 and go up to h is 2. Powers of 1 go down, powers of minus x over 2 go up. Now, we then multiply that by 2 plus 3x minus x squared. The quickest way for me to do that would be with a grid. But when you do write this out, working out, you should probably also, and if you do, you can still use a grid, but also write out the proper multiplication brackets. But in this case, it's easy to just do the grid. And then you'd cross out all those x cubed and that x to the power of 4, because you don't need those. You only need the ones up to x squared. And then you just add up all the like terms, collect like terms and simplify. And that coefficient is 1. So that's our answer. Now obviously, to be more tidy with your working, you can identify that, well, in order to get the terms you want, you can just pick and select the ones you multiply for x to just isolate the terms containing x squared. So that is also doable. So that is the end of the common question types for binomial expansion. Try to do lots of practice and even harder questions.